All right, the law of cosines. Draw yourself a non-right triangle of some sort, and we will label it A. We'll go with old boring. Nope, that's supposed to be a C. Why I always do that kind of stuff. There are three different ways to write this law of cosines. A squared, here's one of them. A squared equals B squared plus C squared minus 2BC cosine A. Does it look kind of familiar? Kind of like the Pythagorean theorem? It's just not a right triangle, so we have to kind of work it a little bit. So this is your Pythagorean theorem of non-right triangles, basically. Does it look intimidating? It's really not. Pretty much. This is, so we use this to solve for any, you're given two sides and the included angle. It's any two sides here. This formula is B and C and included A. You can calculate the length of the other side. Okay. So you're given two sides and the included angle. So let's say to 38. Okay, so let's say 8, 10, 38 degrees. What's the measurement of A? Okay. Now, you could work it if you wanted to. Using this formula. So A squared is B squared, so 8 squared plus 10 squared minus 2 times 8 times 10 cosine 38.
Is that a 10 or a B?
Where? 10. 10 is C. C is 10. Okay, so I have how many different answers? Okay, now square root that. 37 point. 37 point what?
9183. 6.1578. 6.157.
Law of cosines. Plug and chug. It's, again, very similar to the law of sines. You have what you have, you use it. Okay. Can you? Okay. If you look, did you check your mode? What'd you get? Pretty sure that's not right. Did anybody else get? It would be B squared equals a squared plus c squared minus 2ac cosine b.
Okay.
Okay, so the a and the a match, a and angle a, and these are the other sides. Yeah.
Back side, the 2bc cosine A, you multiply 2bc cosine
2 times b times c times cosine a. Yeah. So Jared brought up the other two formula versions of this are in your book on 327, if you want to look them up. If I wanted to calculate, let's say b, I know that this has to be cosine b here. Okay, b and cosine b, those go together, and these are the other sides. So we have b here, we need a and c strung in here. Okay, so I can build this a squared plus c squared minus 2ac cosine b. But it's the same philosophy. You're given two sides and the included angle. You're given a and c and the angle between them. It's the same formula, just written differently. Okay, so if you can use it, you're good to go.
Hey, can you go back real quick?
Okay, so if we had to solve this triangle, how could I calculate C, angle C? Okay, C squared, you could use the law of cosines, because you would have C squared equals B squared plus A squared minus 2BC cosine C, and you would eventually have to use an inverse. The easier one is the law of sines. Okay. You can use the law of sines. 6.157 over sine 38 equals 10 over sine C. So don't forget what we have learned already. You can use that here. That would calculate the measure of angle C. What does, so we're going to multiply 10 times sine 38 divided by 6.157. 10 times sine 38 for the whole thing. So
Sine C is, or times 10 is 6.156.
okay, what, and now sine inverse, right? C equals the sine inverse of 0.999. What is that?
Uh,
87? You get more accurate the more you go.
89.19.
Okay, and then how can we solve for angle B? Yeah. 180 minus 38 minus 89.19. Okay. So you're solving triangles in general. Okay. You getting the idea?
Oh, I put 180.
You can, again, you can still use the law of cosines for angle C if you want. It's up to you. Huh?
It's up there. No, it wasn't. He took it down.
You don't have any angles.
I don't know where I wrote that. Oh, it's right there. I forgot a whole number.
Yep.
I
Okay.
forgot a whole number. Oh, yeah.
You still use
Wait, don't change. Go back up.
you still use the formula. Plug the sides in. So now you're going to subtract these over, divide by that, and then cosine inverse. Yeah, you're just solving equations like we've always done. So if any one of these is empty, you can solve for it. As long as you have 3 of these, you can solve for the missing one. Okay, that was a good question. Thanks for looking ahead.
Yeah, I figured I might do that.
Do you want to know what Hero's formula is? It's an area triangle area formula, another one. I've always okay, this is it. Okay, the first thing you have to do.
Is this a hero's formula?
Yes, it's S. It's a part of the formula. That's S. Okay, thank you. Okay, here's the formula. The area of the triangle. So you have to have 3 side lengths. This applies if you have 3 side lengths. It's the square root, and it's a long one. S times S minus A, S minus B, times S minus C. So you have to calculate S first. It's half of A plus B plus C. Then you have to plug all of them into the formula. Okay. If you have 3 side lengths, any triangle, this always works. Okay. Any triangle. Yeah, S times S minus A times S minus B times S minus C. That'll give you the area of that triangle when you have 3 side lengths.
Could you technically use a lot of sides? So if you're given, like, this one is the area of each triangle and given all the sides. So you could use that, or could you do like the law of cosines and then get all your angles inside and then do the other way?
Yeah, you could do that too. Any one of them works.
I'm glad. I found this entertaining. We just gone over that.
You should be good on those. Give about 10 minutes.